Howdy, statisticians. Sorry it took me so long to get these up, but here we go in your notes. So I would assume that much of this you actually were able to fill in yourselves. The three conditions for means are the same as they are for proportions. So, of course, the first thing I need is an SRS. And I must state that I addressed it, right? So we're doing the question mark with the little high pitched at the end inflection SRS. And then I go hunt to see, did they tell me that it was randomly selected or not? Remember, they get a little loose on that. So even though they might not say SRS, the randomly selected indicates that reasonably it was an SRS. And then I still have to make sure that I'm not oversampling. Remember, this is what affects the independence. So I have to assume that the population size is greater than 10 times the sample size. So that hasn't changed. And then the last piece is checking for normality. But remember, with means, I'm either using mama, so by the population, struggling on the spelling sometimes, being normal, or by central limit theorem, the sample size is greater than or equal to 30. Now, you are going to have some sample sizes that are less than 30. So we have another or in here because t distributions, and we're going to add this to your notes at the end, you'll see there's a spot. T distributions are considered to be robust, which means they are not really affected by skewness. So if I graph, and I can usually with sample sizes that are small, I can look at a stem and leaf plot and I'll check really for abnormalities to make sure that there aren't, and when I say abnormalities, we're really looking for outliers. And so if there aren't any abnormalities, we'll put that in here, if none, then we'll proceed as though it's normal. That's Mr. Torres being funny. That of course means that we have to have the data. So we get a little loose with t distributions. We do want to check that normality and we want to make sure that we address it and state what we think about whether or not we can use t procedures. Okay, so then using our formula, I'm going to erase this extra stuff I wrote in the box. Of course, this is straight off my formula sheet, but now my statistic is x bar and my critical value is t star. Remember, I'm using the degrees of freedom to look it up. And then the standard deviation for the statistic, and since I don't have sigma, I'll have to use s of x over the square root of n. And of course, this is where I have to have that assumption. And as long as you've written it somewhere on your paper, you don't need to keep writing it over and over and over. And so don't forget, my degrees of freedom is sample size minus 1. This little piece right here actually has a fancy name, and you'll see it show up on printouts lots of times as this, SEM. And what it's called is standard error about the mean. So when they start talking about standard error about the mean, that's what they're talking about is s of x over square root of n. So let's look at a sample problem.